Hey, hello, you're welcome to my channel. Thank you for watching this video, and I believe whatever you're going to watch right now, you're going to like it, okay? And when you like it, please don't forget to subscribe to my channel. Just press the subscribe button, the red button there, okay? It's actually free. Just press it up, and if you want to get some notifications from us, you turn on the notifications as well. Good. Okay, I just wish you the best of luck as you go ahead and watch the video. And don't forget to subscribe. You can even do it now so that you not forget. All right, in this video, I want to find the domain of this function. We have the function to be f of x is the Ln of x plus 3, then divided by x squared minus 7x plus 10. Good. So this is a function in a fraction form, okay? And by finding the domain of this function, we want to look at the set of real numbers or every real number that we can plug in order for the result of this function to also be a real number. In fact, maybe I can say find the domain for which the function is real. Good. Okay, so look at the top. We have the logarithmic function, and in this case, the natural logarithmic function. And for a logarithmic function, okay, to be defined, the input should be positive. Good. So let me put it down this way. In this case, we have two cases to consider. Let's consider the case 1. For the case 1, we say the logarithmic function is defined, okay, if the input, which is x plus 3, is greater than 0. So you notice that the logarithm of 0 does not exist, and then the logarithm of negative numbers does not exist as well in the set of real numbers. Good. Okay, so from the first case, which we consider the top, which is the logarithmic function, we have it here that x should be bigger than minus 3. So this tells us that the numerator, which is the logarithmic function, will be defined as long as the x is bigger than negative 3. So we can talk about numbers bigger than negative 3 down or up to positive infinity. Good. But we are not done yet. This is a fraction form, so we have a denominator, which is a function of x. We do not want the denominator to be 0. Good. Okay, so in a fraction, we do not divide by 0. So what we're going to consider here is numbers or cases where this denominator will be 0. And then we will look at those numbers, okay, how we can treat them. And of course, we don't want them. Good. So we look at this as a second case. Okay, we don't want the denominator to be 0. So we're going to find the values of x, that when we plug into the denominator, it gives us 0. When we get those values of x, we will exclude them from the set of all real numbers. Okay, so one way we have to do that is by equating that denominator to 0. First of all, we just equate the denominator to 0, right? And then the values of x that we're going to find, which is the root in this case, they are called the 0 of that quadratic polynomial. So we equate it to 0. And then we can do this just by factoring, okay? Maybe we seek two factors. When we multiply, we get the 10. And when we add, we get negative 7. Well, negative 5 and negative 2 are good candidates. The product of negative 5 and negative 2 gives us positive 10. And then their sum will give us negative 7. And then we are going to put this down this way. X minus 5 times x minus 2. We equate that to 0. From there, we can have that x is 5 or x is 2. So what this tells us is that if x is equal to 2, then this denominator will be 0. And as well, if x is equal to 5, then that denominator will be 0. And if the denominator is 0, then that function will be undefined. So that tells us that 5 and 2 are not in the domain of this function. So we have the case 1, which is x should be bigger than negative 3, and the case 2, x should not be 5, and x should not be 3. So what we're going to consider now is to find the general domain of that function, and this will be this way. Now, considering numbers bigger than negative 3, okay, suppose I have a number line like this. This is negative 3, okay? Let's position 5 here, 2 here, and then let's position 5 here. If we say every real number is strictly bigger than negative 3, then we are going to consider negative 3, but we do not include it. We move forward. Now notice, if x is equal to 2, then that function will be undefined. So x should not be 2 as well. And then x should not be 5, because 5 will make the denominator to be 0. In other words, that function will still be undefined. Good. So what that tells us is that we are going to pick every real number bigger than negative 3, except 2 and except 5. So I'm going to put the domain as to be a set, okay? So you notice the domain is a set containing real numbers called x, right? Such that x is greater than negative 3, okay? X is not equal to 2, and x is not equal to 5. So you notice that we say should be every real number x such that x is greater than 3 and x is not equal to 2 and x is not equal to 5. So that is just by using the set builder method, okay? We can still write this using the interval notation. So you take note, numbers strictly bigger than -3 we mean from -3 forward, all right? And then from -3 to +2, we do not want 2, okay? So we put 2, and we exclude that to using a parenthesis, and then we take union between 2 and 5. We want every number there except 2 and 5. So the parenthesis excludes the 2 and 5, okay? If you are using a squared bracket, that means you've included the 2 and 5. Good. And then we also unite this with from 5 to +infinity. So this right here is the interval notation for the domain of that function, okay? X lies in there, or maybe we can just write it the other way. Okay, great. All right, thanks for watching, and please subscribe to my channel.